Welcome back to College Algebra, MAT 150. In this lecture, we will be discussing completing the square. So before we complete the square, we have to talk about what a perfect square is. And a perfect square is just a number or expression that has two identical factors that multiply to be that original number. So for example, 9 is a perfect square because 9 is equal to 3 times 3, which is the same as 3 squared. So since these are the two identical factors that multiply to be 9, both factors being 3, then we say 9 is a perfect square. What about x squared minus 10x plus 25? What are the two identical factors for this? So this is a trinomial, and we know that x squared minus 10x plus 25, so since it doesn't have an a, two numbers that multiply to be 25 and add to be negative 10 are negative 5 and negative 5. And so this factors into x minus 5 times x minus 5. And since these are identical factors, anything times itself is itself squared. So both 9 and x squared minus 10x plus 25 are perfect squares. And in a lot of trinomials we'll be dealing with, they're perfect squares when they're of this form. So a lot of them we're not going to necessarily look at having a's, but we could. We're going to look at mostly ones that deal with x squared and then have the form that this is just twice this. So for example, like the 10x plus 25, what are the two numbers? Negative 5 quantity squared, so the negative 5 is the b, is when you square it is 25. And when you multiply negative 5 by 2, you get negative 10. So this quadratic expression up here is exactly the same as is exactly in this form. And the whole point of looking at this, so we see these perfect squares. What do we want to do? We want to try to force a perfect square so that we can take any quadratic of this general form, so ax squared plus bx plus c, and transform it into a times this x plus k quantity squared plus h. And why do we want to look at it in this form? So if it's in this form, we saw that we can, and if we're trying to solve and it's equal to 0, we can try to factor. But factoring doesn't always work. But if it's in this form, we know that we can use the square root method by isolating the square term and then square rooting both sides. So that's one of the main reasons that we want to do it. There are other reasons to complete the square as well. So what do we actually have to do? Well, if we see a polynomial of this form, x squared plus bx plus c, we're going to try to force this to be a complete square. And we're going to try to do this by adding and subtracting out the appropriate c term such that it collapses like the one up here. And there might be a little bit left over. So how do we do this? So if we see x squared plus bx plus c, first group the x terms. All right, and then the important part becomes the b. So the b number, you divide it by 2, and then you take that after you've divided it by 2 and you square it. So you have these two little things, and these are both important numbers, the b over 2 and the b over 2 squared. And then we add the b over 2 in, and we take it right back out. So if you add something in and take it right back out, that hasn't actually changed the equation. So notice the x squared plus bx plus c are still in this equation, are still in this expression down here, but we're just adding in the b over 2 squared and taking it right back out. And as it turns out, this whole portion, since this is literally half of what that is, remember, of this form, we want to have it of this form because this factors into x plus b quantity squared. Instead of looking at it like this, we're now looking at it, the b is the b over 2, and b over 2 plus b over 2 is b, so it factors into x plus b over 2 quantity squared. Excuse me. So, and then x plus b over 2 quantity squared minus whatever this number plus this number, this is the completed perfect square. So let's take another look. Excuse me. So when we complete the square for x squared minus 10x minus 2, we have, so we notice that this 10x, this minus 10x is of a form we've seen before. Remember, x squared minus 10x plus 25. But we don't have the plus 25, we have minus 2. So let's follow those steps. Step 1 was to group the x terms, so let's start with that. So we have x squared minus 10x. Then we have the minus 2 on the outside. Then what we're going to do is we're going to take the b, so just the number, we're not dealing with the x. We do a couple of things. So take the b and we divide by 2, and we get negative 5, which is an important number, which we'll circle. Then we also take that number, so after we divide it by 2, we square it. What happens when we square negative 25? Well, it's or negative 5, it's positive 25. And this is also an important number. Now the negative 5 will be important here in a minute, but the 25 is the number that we're going to add in and take right back out. So we got minus x squared minus 10x, and when we add in the 25 here, we're also going to take it right back out. And again, notice I'm adding it in and taking it back out. It does nothing. So what I do have here is something that is exactly the same, but it looks different. And that's important enough because x squared minus 10x plus 25, we saw, factors into x minus 5 squared. And notice, when we divided by 2, we got negative 5, which also is what we have here. That's no coincidence. That always happens. So if you're ever confused about what this part actually factors into b, what the perfect squared is, it's just this portion. So that's why I say it's an important number. So we have x minus 5 quantity squared, and then we just simplify negative 25 and minus 2, which is negative 27. So we have x minus 5 quantity squared minus 27. And that is the completion of the square. Now, being able to do this in a vacuum is pretty important. So here we added in and took right back out. However, a lot of times when we're solving, we're going to go through a different process. We're going to have an equal sign. So we're going to have equivalent equations, and it's going to be sort of a different feel. In here, we can actually deal with the a. So what we do, if we're trying to complete the square, so now that we have an a, what we do, we first start by grouping the x terms, and we do that by actually just bringing the c over. We're subtracting c from both sides. And then we don't like seeing the a, so we divide every term by a. So once you subtract c, divide every single term by a, and that gets rid of the a in front of the x squared. And then, so get c to one side, divide by a, and now we just complete the square for this. So we just look at this stuff, the b, sort of b term in quotation marks, which is now b over a, and divide by 2, square it, complete the square, and then you're going to have something like this, but with an equal sign, and you can use the method of square roots. So the principle of square roots. So let's actually run through an example. If I have x squared plus 8x minus 2, let's go through this. So first, get the c to the other side. The minus 2 is the c. So we're going to add 2 in this case. So x squared plus 8x equals 2. Then the second thing said divide every term by a. Well, is there anything in front of the x squared? Nope, so we don't have to worry about this step. The third step is completing the square for the left side. So we're going to complete the square for this side. And so to do that, we look at the b term. And the b term is, or the b coefficient rather, is 8. So we take that, and again, it's always divide by 2, and 8 divided by 2 is 4. That's an important number. Then what do we do with the other one? Just like we did above, we square it. 4 squared is 16. That's also an important number. So what happens to this? So we get x squared, and now this is where it gets a little bit different. We could add in 16 and then take out 16, but because this is an equation, we can simply do this to both sides. We can simply add 16 to both sides. So we're taking this and adding it to both sides. Then 2 plus 16 is 18, And we have x squared plus 8x plus 16. What does this factor into? Again, another thing from before. What does x squared minus 10x plus 25? Well, it's whatever we divided by 2. Whatever we got when we divided by 2 to the b part. So negative 5 was here. What did we get when we divided 8 by 2? We got 4. And that tracks what are two numbers that multiply to be 16 and add to be 8? 4 and 4. So this whole side factors into x plus 4 quantity squared. So now what we have is x plus 4 quantity squared equals 18. Then how do we solve x plus 4 quantity squared equals 18? And this is the beauty of the principle of square root method, so solving by square rooting both sides. So when we do this, so there's a square term that's isolated, so we can employ the square root method. Square root both sides. When we cancel the square and the square root, that leaves x plus 4. And on this side, you have to put a plus minus at this point. And we have the root of 18. Now, unlike before, so we still have the plus minus here. Remember, this implies that there are two solutions we have here. But the square root doesn't go away. And further, we have 18. So we're going to deal with the simplification of this radical here in a moment. But to finish solving, we have x plus 4. We have to isolate x. So subtract 4. Now, the 4 and the root of 18 don't really interact. So we just usually put it in front, at least not as is. You can get a decimal approximation and look at this. But we have negative 4 plus or minus the root of 18. And what we can do now is start to simplify the radical. So notice that, again, I'm still keeping the plus and minus notation here. That just means I have two solutions. One is with plus, one is with minus. These are not one collective solution. So if you need to find out the two solutions, again, just do one with plus, one with minus. But we can simplify 18 by looking at what are numbers that divide, that we can square root nicely, that divide in 18. Well, 9 is a number that square roots nicely. And then we know that we can square root each one of these. So it's the same as the root of 9 and the root of 2. Again, you can split up radicals over multiplication or division. And then x equals negative 4. What is the square root of 9? It's 3, so plus or minus 3, the root of 2, are the two solutions, one with plus, one with minus. All right, so that's 1. What about number 2? Well, number 2, we have 4x squared minus 16x minus 20. So let's go through this process again. Let's bring it back into view. So what do we do first? Well, we get the c to the other side. A is 4, B is negative 16, and C is negative 20. So what do we do? Well, we add 20 to both sides. And that's the first thing. It says subtract, but in this case, since it's minus, we add 20 to both sides, just like the other side. So we have 4x squared minus 16x equals 20. What does it say the next step is to do? We divide by a. So what's the a in this case? Is there one? Well, yes, there's a number in front of the x squared, so that's what we divide each one of these terms by. So 4 divided by 4 is just x squared. Negative 16x divided by 4 is negative 4x. Again, mostly just 16 divided by 4. And what is 20 divided by 4? Well, that's 5. So now that we've done this, so we subtract, so we got the c to the other side, we divided by a. Let's complete the square for the left side. So what's the important number for to help us complete the square over here? It's the negative 4. So don't forget to include the negative. What do? We divide by 2. What is negative 4 divided by 2? It's negative 2. Then what do we do with that? We square it. Negative 2 squared is 4. Again, the negative 2 and the 4 are the important numbers. What do we do with the 4? Well, we deal with this first. We deal with this later. We add 4 to both sides. So x squared minus 4x, we're going to add 4. Then we're going to, on one side, we're going to add 4 to the other side. And when we do this, the right side is going to be 9. What is x squared minus 4x plus 4? Well, this is now a perfect square. And what does it factor into? Well, what are two numbers that multiply to be positive 4 and add to be negative 4? Well, negative 2 times negative 2 multiplies to be positive 4, and negative 2 times negative 2 adds to be negative 4. And that is our factor, x minus 2 times x minus 2, which again, we found this just by dividing by 2. So you can just go straight from here to here once you know this number. Now, how do we finish solving? We complete the square. We've done that, so now we solve by the method of square roots. So we square root both sides. And again, once the square and the square root cancel, we're left with x minus 2, and then we get a plus minus on this side. Once the square and the square root cancel, that's when the plus minus appears, technically. Now, over here, we had the square root. So when we solved, and it sort of persisted throughout. But here, the square root, we can square root 9, it becomes 3, it went away. And as a reminder, when the square root goes away, this is when you want to separate it. So we're going to separate it into two equations, one with the positive, so things don't go awry, and one with the negative. So one with the positive 3, and one with the negative 3. Then we just solve each one. Add 2, so x equals 3 plus 2 is 5. That's one solution. Here we're going to add 2 to both sides, and we get x equals negative 3 plus 2 is negative 1. And that's our other solution. All right? That concludes everything from this lecture.